Hello, welcome back to More Fun Fixing It. This is part 3 of, well, I thought it was going to be a 5-part series, but this is going to be part 3 of 4. Now, I have 5 silver label C64s to repair, and this is the 3rd one. The 4th one, which is now going to drop out, is actually working. I forgot that during the triage, I fired it up and discovered that the only problem with it was that it was missing a working SID. So with that in there, it passed all the diagnostics. So that's not actually going to be a repair video. So this machine number 3 is the 3rd machine that has capacitor damage. But we'll get into that in a second. The 5th machine, which is going to be part 4, this is getting very confusing, is going to be the Revision A machine. I'll show you it. This is it, the lovely Revision A SA 326298, and the serial number is 0882. It's very, very early. This one's been around on my channel for a while, and I should explain that I previously made a video where I triaged this and I asked for help from viewers to tell me what they thought the problem would be, and I have gathered all of that information together, and I'm going to use it in the video when I come to repair this. But the idea for all of these machines was that I repaired all of these other silver labels, which are slightly later boards but still quite early, before I attempted to repair this one. I wanted to make sure that my repair chops were up to scratch. Anyway, let's put this one away. Oh, if anyone's wondering, this is not the original SID out of it. This is a spare SID. Actually, I'll probably need to use this in one of these. This is a spare SID that I just put in here temporarily for diagnostic purposes. The original SID is safely in a box. It's an 82 SID, and that does still work. This video is sponsored by PCBWay. A little behind the scenes story from the workshop. I was recently sent by my friend Martin a C64 mini PCB, and I thought it would be fun to drop it into a full-size bread bin case. The only problem was the keyboard. How do you connect an original Commodore 64 keyboard to a modern mini board? After a bit of digging, I found that somebody had already solved it, and they'd uploaded the design to PCBWay's shared projects library. There it was, a ready-to-order PCB that converts a real C64 keyboard to USB using a Pi Pico. Exactly what I needed. No extra work from me. And honestly, it couldn't have been easier. A few clicks, ordered a batch of 10, job done. The price was super low, and even with the budget postage option, the boards will still arrive well before I even start the modification. That's what I love about PCBWay. Whether you're designing your own boards or grabbing something clever from the shared projects library, it's incredibly quick to go from idea to actual hardware in your hands. So if you've got a retro project, an adapter board, or a completely new design in mind, check out PCBWay, and don't forget to explore the shared projects section. You never know what brilliant solution someone has already made. On with the show. So this one, which was part of a triage episode, is a KU14194HB board. This is I think these are referred to as Revision B or something like that. I'm not sure. I still haven't got the lineage of the early boards perfectly set out. The ones that I see the most of are 250407s and later. It's quite rare for me to see these, and there are now 3 of these in the workshop right now. The case on this one is in really good condition. Half of the clips are missing. Out of these 6 little retainers, 3 are broken, so I'm going to have to do some repair on that. The actual case itself is in really good condition. The labels look nice. They're not metal again. And the keyboard is in really good condition. The lettering on the keyboard is still bright white. It doesn't look like it's yellowed at all. There's a little bit of damage down here. Looks like cable burns. So that will probably buff out. And apart from that, this is a really good one. But we'll get to the keyboard a bit later. The problem with this one is, as it said on the label on the front, black screen. And it's not just a black screen, it's actually no video output whatsoever. So if I plug it in and switch it on, making sure, well, it was already switched on. So I switch it on now, there's, you can see up here, I haven't got it plugged into capture yet, but you can see there's no output on the screen at all. Now, that is almost certainly because of the same reasons as the previous one. Let me just get rid of some of this stuff. The previous one where I changed this 74LS629, which I learned is not a logic chip. This is apparently a voltage controlled oscillator, which takes a frequency, a clock signal of a certain frequency, and checks it against another clock signal and uses some kind of wizardry to change the level of the clock to be what the reference clock should be. It's to stop the clock drifting out. Now, this whole section of the circuit here with the VIC-II is all about generating the image, but the other thing it does is generate a system clock. So the crystal, the main crystal here, which is a 17.73447 megahertz crystal. Is it megahertz or hertz? It's megahertz. 17.3447 megahertz crystal feeds that signal into this 74LS629, and then it does some magic. It uses this clock signal to generate the color signal and the dot signal, and the dot signal is then sent into the VIC-II, which generates the master signal, the master clock signal for the CPU. This is all, I mean, I don't try to get too far into the weeds on this technical stuff. I like to know how things work, but when it's things like this, I do start to struggle with the science. But that's fine. You can be a non-expert like myself and still fix things. It doesn't matter. People will judge you, though. Anyway, let's have a look at what's going on with this part of the circuit. Well, you can see there, straight away, that there is some nasty crustiness going on these 3 pins of this chip. And this cap here has leaked. In fact, it's really rocking about. I wonder if that's just gonna break off. I'll just keep wiggling it. Yep. Oh, that is really nasty. Well, I can see exactly where the problem is here. Well, there's your thumbnail. The other side is another capacitor, and that one is nice and solid when you rock it. And look, there's no leakage going on here. I am still going to change it because I think I can just see the starts of some, yeah, look, there's some crystals just hanging around down there. So that one has started to leak. Now you might think to yourself, oh, if this capacitor has leaked, what about all the rest of them? And I was under the impression that all of these would be okay, but they're not. If we look, now most of them actually are tight down to the board, so you can't see underneath them, but a couple of them down here are actually not so tight to the board. They're bent over. It must be because the edge of the frame of the keyboard actually fouls them if they're standing up. So I'll have to remember when I change these, and I am going to have to change them. Let's have a look at these ones down here. This one on the left, C34. You can just see there's a little bit of blue goo just starting to come out, and the crustiness of this solder is, while it's not terminal, it's not corroded yet, is a telltale sign that something is wrong. If we go across to the other one, and again you can see it is just starting to leak. Just those bits of blue inside there are telling you it's starting to leak. And if these two have gone, where they're not really against any heat sources, then all of the other ones are at risk as well. So I'm going to have to change all 14 of these. I think they're all 10 microfarad capacitors, as well as these two shorter ones in here, which are also 10 microfarad, I believe. Yep. So it's a complete recap job, but I'm still not going to change these big ones. These 3 huge ones here and this slightly bigger one here, because Well, I might change this. If I've got one of these in stock, I'll change it. That says it's 100 microfarad, 16 volt. I might put a reclaimed one in there, but I'm not going to change these ones. There's nothing wrong with them. These ones here look completely different to these ones. These have got black tops on them. I wonder if that is just where someone's, yeah, it looks like somebody's actually coloured them in with a Sharpie or something. Anyway, the next thing we need to worry about is this. Let's get that done. I'll worry about the recap after we've sorted this and actually got something out of this. And just to show you that there are no signs of life, if we have a look at the scope and look at the, where are we? The 6510 CPU over here has its clock on pin 39, and if I scope that, there's absolutely no movement there at all. It's completely dead. And if you go back to the VIC-II, where the clock comes from, the clock out of the VIC-II, pin 17 on the VIC-II is the clock out. So 19, 18, 17. Oh, there was a small burst of activity then. I think that's the VIC-II actually just initializing, not seeing the clock and then shutting down. That's quite interesting, actually. Yeah, it really tries to work. And the clock in to the 65, into the VIC-II, yeah, pin 21 is the dot clock in, and that should be generated by the associated circuitry next to it, and that's absolutely doing nothing. Okay, so I skipped over all of that I've kind of skipped over it a little bit in this video as well, but I wanted a slightly better understanding of what was going on with this. So anyway, okay, so because this worked so well last time, this Gaugy S993A, I'm going to use it again for this board. I was going to, for the next one, I was going to use, I can't find it now. I was going to use a modified ZD915 that I have here. I need to use all of these so that I can do a proper comparison video between all the desoldering stations. I have some kind of weird and wacky desoldering solutions as well to go in that video. By the way, before I go any further, I have taken out all of the chips that are in sockets on this board. So the 2 CIAs, the 3 ROMs, the CPU, the PLA, oh, and the SID. I've put them in another board and tested that they're working. They're all good. I'm predicting once this is fixed and replaced, that this will spring back to life. It could be that it's just that capacitor that has shorted out that's caused this problem, but it could, I suspect it's this chip. I think these are quite fragile. Anyway, right, so make this a little bit easier to get out, I'm just going to reflow all of these, the legs of this chip, and straighten them up with the end of my soldering iron. These 4 pins here are bent right over, so I'm just going to put a little bit of solder there and then use the melted solder that's already on there to help me stand the pin up. Otherwise it won't stand up. If you just try and stand it up like this, it won't move because it's fighting against the already solid solder. Yep. Well, this one's completely flat on the board. I'm going to have to lever this up. There we go. Spin it around for the other side. Solder is in good condition on this side, so I think that there's not going to be too much damage apart from around where that cap is specifically. In fact, we need to remove those bits of leg. This one here actually does look like it has got some damage. So this is the other side of that cap, and you can just see that this has gone a bit crusty compared to like something over here. There's something going on here. Something has leaked through. It amazes me that it's able to get through the board in the way it does. So I'm going to just heat this side like this, because the cap is off on this one. And just pull that leg out. You can already see there's not the corrosion has just eaten through that via. I'm pretty sure that's going to be pretty terminal. Bit of repair work needed there. The other one. There we go. That's that leg out. I'm just going to use a solder sucker here to get these cleared. Oh, we had a bit of via there. That's a bonus. I think the connection is actually on the other side, but it's whether the solder is going to reach through to the other side and make that connection. And that one looks good as well. Okay, we've got one more over here. The bottom two pins of these three, this one and this one, are also the other capacitor. So let's reflow those. And use the gougie to get the chip out. Okay, previously on the video before this, the gougie worked so well the chips just fell out. So was that just that board, or? Well, I think this is just a bit more of a stubborn board. I still think it's performed very, very well. Yeah, okay, so the problem here is the solder has not melted where that destruction is. So maybe I should just clean that first. Give that a little brush. That's a bit of a shame. I think some desolder braid and a little bit of heat. Let's turn this around so I can get access to it. A little bit of braid up against there and see if we can get that solder out from this side. The braid is really good for this sort of situation. No. That doesn't not look very good. I'm resoldering a lot of these pins because they're just solid, so I want to make sure I give this every chance of coming out without having to lever it, and I don't want to use heat on the top side unless I have to. I don't think I've got a choice. It's out, but this chip is toast. I'll show you the chip in a sec. Let's have a look at the board first. Okay, so first problem we've got is quite a lot of corrosion around here. I think there's a trace going through. Is that a trace? Don't know. That actually looks intact. We haven't got as much damage as the previous one. This should be, yeah, this cap is now free, so. Oh. Okay. Yeah, that one was leaking as well. There's your other thumbnail. All right, I need to mop this up. I'm actually going to turn it over and bang it. Yeah, there's a pile of debris on my desk now. Not quite as bad as I feared, actually. The pads are still there. And the only trace damage I can see is the same one that went on the last one. This bit here, under this bit of silk screen. This is where we lost that trace almost completely. I wonder if that's actually gone already. Grab a multimeter. Make it sure it's in beepy mode. Oh, that's still connected. But it might just be hanging on barely. Yeah, that trace under here is also quite dark. The other traces, there was a lot of damage on these ones up here and these ones down here on the other one. Hasn't got that far. Must just be the way this was tilted, or I don't know. There's a little bit of damage there, but it's mostly going to just be superficial. Yeah, it's just mostly the silk screen. But I'll have to remove it just to make sure there's no, to stop any future corrosion. And this bit here. I had some comments on the previous video about how to use different instruments to remove this, because the end of tweezers is not ideal because it does scratch the copper. But I'm being so gentle when I'm doing this. I'm barely doing anything to the paint itself, and although I am going to be scratching the copper, I will make sure that any exposed copper gets a coating of solder and then gets coated over the top of that, so that it's strengthened, it's given some more metal to conduct, and it's then protected as well. But I just need to make sure that there's no actual permanent damage, or no damage that's going to continue to happen underneath this silk screen. And this bit here is going to be where most of it is. Also this bit. It's a trace that runs, a thick trace here. This is ground, I'm fairly sure. Yeah, the minus side of this cap and the minus side of this cap are both connected to ground and to these 2 points on the chip. And last time I couldn't find my fiberglass pen. I found it now, so I might try that. But it will mean scratching more than I lose a little bit of control, a little bit of resolution. But I think just around these bits, I might just polish these up. It's not an abrasive, very abrasive fiberglass pen. It's really mild. So it might be worth trying that. Let's give that a little clean. Using a nano sponge this time because it absorbs the goop. And also polishes. Right, a little bit more here. And I still don't think this is exposed. This is dirty copper. That won't take solder. I need to get down to fresh copper. This is corroded copper. You can still just about start to see the right colour copper down here. Okay, some of this is looking good. This is over here is looking quite nice. Still some bits on it. If I run the solder over this now, it will be patchy and won't look right. There's little dark spots on here which won't take the solder. I'm being so gentle here. And this bit here, get to it. This is where the problem was on the last one. Right here. It looks like a similar thing. It's rotted through most of the way. It might not have gone quite as far as the last one. Just want to get rid of that dark patch there. A few of these spots here. Okay, that's looking better. It is looking better. Just spraying that to pick up some of the fiberglass strands. All right, I'm going to flood all of that with flux, which turns highly corrosive at high temperature and will oxidize all of these points. Try and get solder to flow into these holes so that it gives that a chance to clean out as well. Why does that not want to come off there? Get on there. There we go. That's actually not too bad. It looks horrible, but that one really is full of crud. See, it's not taking at that same point there. It's not taking the solder, but it is. That'll just need a little bit more work. Braid, mop up as much of this as I can. Looks worse, but it is actually better. Oh, look at that. Didn't even see that. There's another trace going under there that's damaged. The corrosion has worked its way along out from here, and it's gone this way as well. You can see all the pitting along there. That's where the copper is starting to corrode. Left alone, this in however many years, this trace would just disappear. All right. A little bit along this edge here. A little bit here. Still. It's like the pad has gone on this side. I'll have to check it's still connected from here to here. I think there's a chance it might not be. I've still got to clear out the holes as well. Let's check if that's got continuity. Ew. No. Okay, so there's a break there and there's a break there. Is it still connected? Yeah. And there's two ways of doing this. I can either run a bodge wire from this pad here once this chip is in, or actually no, there's going to be a socket there, so that's going to make it a little bit more awkward. No, I'm going to do it on the other side. I'll run a bodge wire from that pin to there and then to there. So I'm not going to worry too much about this side now, because I could fix these here, but then once I put the capacitor there, they could just float away once I reflow this via, and I doubt that this is actually connected to the other side anyway. So these are actually completely redundant. That pad over there is gone as well. Fortunately, not connected to anything on this side. So I don't need to worry about that one. I just need to get the solder out of there and out of there. And yeah, start cleaning up, and check the other side as well. Let's check the other side now. Okay, so that's the capacitor, and that looks like it's completely lost. Oh no, the wire is still there, the pads. It's still there. Okay. This is the one that's lost on the other side, I think. Yeah, I think that's the one that connects from there to there to there to there to there on the other side. So I can just run bodge wires if I need to. Where's the other capacitor? This is the other capacitor. Probably need to clean this. So that all looks good on this side. I don't see any problems. I just need to make sure I take a photograph of this side so that I know where to put the bodge wires on the other side. Now, this tiny, tiny drill that I use to clean out the holes. I'm just going to run it through all of these. The only ones I'm struggling with are the caps on the cap pads on the left-hand side. Oh, that one's gone. That's good. Yeah, better from this side. Excellent. All right, the next thing I want to do is just to check continuity from, well, actually, let's check all the continuity on this side, just to make sure everything's connected where it should be here. And I'm pretty sure this is all okay, because these are all big, thick traces, and they all seem to be going where they should be going. Oh. So that we know that that one's broken. That one. And I can check that one. I don't know where that one goes, but that's not showing any signs of damage, so that's all good. I don't need to worry about anything else up here, I don't think. I just need to check all of the traces on the other side. Oh, sorry, I just need to check the wires to make sure there's continuity through the board for each one. Excellent. Okay, so now the only thing I need to do really now is cover all this up with solder resist. Oh, there is that another trace there I've missed? From there to there. Yeah, look, there's a trace. Yes, I need to clean that up first. Looks in good condition. Not worried about this one. Just take that top corroded layer off of it. Small dark spot just there. Still there. That's got it. Yep. Okay, final clean with a fresh nano sponge. Yep. Ah, two I've lost. and paint it. Okay, happy with that. Super duper death rayo vision. I'll leave that for a few minutes, probably no more than one. I think that's done. Let's just check it. Yep, all solid. Sock it to him. Okay, now I should have a couple of low profile 10 microfarad caps here. Pop those in. Okay, everything's back. I just got to link up those 2 points over here that are broken. I think it's on the positive side of the cap, but I'll check on my photograph. So I need to connect this pin to here, and if it was just those two, I'd just run a component leg across the top there and keep it away from the traces. But it also has to go down to here, from here to here, and if I run a component leg here, it could theoretically short on one of these 2 pins here. So I'm going to use some enameled wire instead, and I'm going to remove the solder from this leg here, and this leg here, and this leg here, and I'm going to wrap the ceramic wire, the enameled wire, around all 3, and then melt it. Melt the solder back on, which will take off the enamel coating and link them all together. Let's do that. That one. That one. And that one. There we go. Those 3 pins are now lacking a bit of solder, so I can get the enamel wire wrapped around them. It's quite chunky, so I'm going to do a loop around that leg there. Like that. And that's the point where my main camera quit, taking my microphone with it. So this section of the video is basically me fixing those broken traces that I've discovered on the other side, using some enameled wire to twist around these legs and melt them in place and refix those tracks. It's pretty much all there is to it. But I'll leave you with it so you can watch me, the master, at work. Master. Beep, 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 beep. Still no microphone, so in this bit I'm looking at the old 74 LS629 chip and wondering if it's actually broken. So I'm cleaning it up and I'm going to put it back in the board to see if it does work. All right, for some reason my main camera cut out just at the end of that. I've repaired the trace damage, and I've put the original chip back in after straightening up its legs, and I'm going to test it now. Will it work? Oh, yes. So it was just, could have been the caps or that cap especially that one on the left, could have been killing the clock altogether. But the 74 LS629, this voltage controlled oscillator, is actually is working. That's really good. Okay, diagnostics. I think this is just going to be fine. I think this is going to work first time. I'm going to go straight for the harness test. Here we go. I have to say, that's a pretty good... I mean, you're looking at S video on the capture, but over here on this screen, I'm looking at composite on an LCD, and it looks really good. There's a little tiny bit of fringing, like over sharpened fringing, but it's really nice. And this is an R1 VIC-II. Oh, RAM test 1, bad. RAM test 1 is bad. Nothing wrong with this. Let's just do the no RAM check, just to make sure nothing else is broken. Oh yeah, it's not happy. Okay, let's go to DES test and see what that says. CIAs are counting up well, that's good. So the max test looks like it's going to pass. That's the first 4K is okay. I think the cartridge slot was a bit crusty. Okay. Right, I don't know how much... I'm having some camera problems today. My overhead camera has now decided to overheat on me. I might have to get some cooling solutions for these. Anyway, so I've connected up the test harness, and I keep getting a control port and user port issue, serial port and user port issue, U1 and U2. And I've put in a different CIA in U2, and that made no difference. Take this one out, put it in this, swap it over to the other socket, and put this one back. And yep. Sometimes it quits on control port as well. It's really weird. Something just makes me feel that it's a cartridge slot problem, because I know these CIAs are good, and apart from it being, you know, maybe a chip that's associated with them, I'm not sure exactly what's going on here. Okay, that's enough of that. So I have, heatsink is toasty. That's really hot. So I've spared you quite a lot of this, because for quite a long time I was going around in circles trying to find out what was wrong. Now the symptom is on the diagnostics, which if I can just run it now, that'll be fine. Not that one. On the diagnostics, it says cassette bad and everything is there because I haven't got the harness connected, but it says serial port and user port is bad. Now, it says that with the harness connected, and normally that would point to CIA1 or CIA2 or both being faulty, and they're not. So normally if the user port and the serial port are bad, you're looking at the CIAs, because here are the CIAs, U1 and U2, and they are connected to the keyboard, the user port, and they go up here to the serial port. They're also connected to the controller ports as well. I wasn't getting any problems with the controller ports, and I wasn't getting any problems with the keyboard, so it kind of ruled out U1. But these are both in sockets, and I've taken them out and swapped them over, no difference. I've also taken them out and put different ones in, no difference. The only chip that's common to both of these chips is U8 here, which is this one here. And that has something to do with the data and the clock and everything for the serial bus. And I've I've actually taken that chip out of the board and tested it, and it's fine. I've put another one in, and that does exactly the same thing. So I'm confident it's not U8. I also checked the signals between two identical boards, two of these KU boards. I scoped them both at the same time. Can't find any differences. I can't find any problems at all. So I thought, well, what are the symptoms of this? How is this manifesting as a fault? Because just because it's coming up in diagnostics might not mean that it is actually a proper fault. So I attached, the only thing I've really got that attaches to a serial port is my Pi 1541. So I plugged that in and loaded up a game, and it worked fine. Now, just in case it was something to do with the cassette port as well, I loaded a game on cassette as well, and that worked perfectly, which is what you were just listening to at the start of this bit. I'm a little bit of a loss with this one. It's working in every single way that a C64 should be, as far as I can tell. I haven't got anything left to plug into it. I haven't got any other diagnostics that I can really throw at this, and I can't find anything actually wrong. I'm hoping that it's a board revision thing and something that they may have fixed on later revisions that the diagnostics is getting confused with. That's a possibility, but I'm here to be corrected. If you know better why the user port and the serial port would come up faulty, but all of these chips are, I changed out the PLA as well, because that can cause issues. Everything is working fine. I really don't think I've really paid a lot of attention to making sure the sockets are clean and the pins of the legs are clean, and they all seem to be good to me. So this one, I might have to just walk away from this one, which doesn't sit well. So it's the next day, and I've got a bit of a cold, but this now works. The things that I've done since between yesterday and today, I've ruled out, or I started to rule out everything I could. So all of the passive components that I could see, things like R29, R30 and R28, which are down here, I make sure that they're okay. There's a resistor pack here, which is marked here as RP3. I took that out of the board and tested it because it didn't measure properly in the board. The first pair of points were actually measuring slightly lower. And I took that out of the board, measured it out of the board. That's fine. That was on suggestion of Todd from Yet Another Retro channel. Good suggestion, Todd. Lots of people helped me with this. I actually went to Retro Hardware Discord and asked in the Commodore section in there if anybody had any ideas on what this might be. And that's where the solution came from, because I mistakenly said that the only things common to both CIAs is U8 and the passive components that are connected to that side of the chip, of especially U2. But there are other chips that are connected to these two, and well, all of the other chips are connected to them, because everything on this side of the bus is the CPU, the PLA, pretty much everything. The data and address lines are all connected to them. So it could be pretty much anything. Just because these are working fine, the signals that are driving them might not be. Now, it was a user called Hawk on the Retro Hardware Discord who said that they'd had a C64 in which they had to change the CPU to get the a similar problem fixed. I thought, well, I've changed the CPU, but I hadn't. What I'd done is I'd taken the CPU out of this one, put it into another machine, turned it on, oh, it's working, and turned it off again. That's the only test that I did. I didn't do any diagnostic tests. So this is my test machine, and it has the CPU out of the broken machine in it. And if I run this with the full harness connected, and no RAM check, the exact same fault comes up. Serial port bad, user port bad, U1 bad, U2 bad. It was the CPU the whole time. What I'm going to do with it is I'm going to send it off to Chrissy Baps, another Retro Hardware Discord member who has a backbit retro chip tester thing, Pro, whatever it's called. And that can test all sorts of chips, including 6510 CPUs. So I'm going to send it to Chrissy, and Chrissy's going to test it in that. I might actually try and get one of those backbit testers myself, but they are really expensive. So I might save my pennies up. Maybe I'll get it, buy it for Christmas for myself. There's all sorts of things I can test with that. So it would be a boon for my workshop. But we've found the culprit. The machine has a different CPU in it now. I need to source a better, one that's not my test machine CPU. But this now fully works. Oh, the other thing I did was change all of the capacitors in here. Somebody did mention there's a couple of capacitors inside the RF modulator, so I will have to look at that at some point as well. But I'm not going to do that right now. If they look like they've been leaking, I'll change them. I probably will change them in this one because all of the caps were leaking. I've changed every single one of these 10 microfarad caps. I am quite tempted about changing these, but I'm going to talk to Paul and see what he says. It might be down to the person that buys this to change the rest of the caps if they want to, but we'll see. But for now, this one is fixed and fully working, passes all the diagnostics tests, and the keyboard works perfectly, and it's ready to go. So the next one that we've got to fix, actually, I can cut back to what I was talking about earlier when I did the first version of this video. Carry on, Lee. Speaking of the next one, this is the next one. This is the Revision A C64. And that's going to be fun. Right. So yeah, I'm gonna leave this one for now. Thank you for watching. If you've made it all of this way, please leave a like and maybe a comment, or send good wishes. Clap to yourself. I don't know. You can do what you want, but be happy and be nice to your fellow man. Thanks for watching. I'll see you in the next one. Bye. I'm solving world problems now. Everybody, stop fighting wars.